Hi, in this video we're going to look at how to solve some more problems involving the conservation of mechanical energy in physics. So, at the city pool, a brave 25-kilogram girl decides to jump off the high dive, which is 1.8 meters above the water. She jumps off the diving board at a speed of 2.2 meters per second. If air resistance can be ignored, what is her kinetic energy just before splashing in the water below? So I've drawn the picture here and I've labeled before and after. You could also say that this is the initial state of the girl. And then right here, right before hitting the water, this is the final state. Those are other words we use for before and after in physics. And we want to know, what is her kinetic energy right here at the end? So I'm going to label my picture here. The kinetic energy final is what? That's what we're looking for. Now, we can use some of our knowledge about physics to help us answer this question, because her final kinetic energy is going to be related to her starting mechanical energy. And that is to say that the total mechanical energy of this girl beforehand is equal to the total mechanical energy after. I don't know why I decided to write it out like this, but that's what we'll say here. So the total mechanical energy before is equal to the total mechanical energy after. So that means that if you added up her kinetic energy and potential energy before she jumps, it will equal the kinetic plus potential after she jumps, or right before hitting the water. Okay, we can also make another conclusion based on the information we're given here. When you see words like just before striking the ground or just before splashing in the water below, we're assuming that at this location right here, the height of the girl is 0. And that lets us say that the potential energy of the girl right here at the end is 0. And that's important because it helps us get rid of this term completely. This is just 0. So we can kind of get rid of that whole term, the whole potential energy there at the beginning. So kind of simplifies our equation a little bit. Now to work out from here, we can break this down one more step and say, okay, kinetic energy, that's 1/2 times the mass times the speed squared. The potential energy is mass times acceleration due to gravity times the height. And we have the same thing over here, but instead it's going to be the final speed of the girl. However, we don't really need to do that quite completely because we're asked to find the final kinetic energy here. So I just kind of did this out of habit, breaking down the equations, but we actually want this value. We want the kinetic energy. So we're going to keep that as the final kinetic energy there. So to find the final kinetic energy, all we have to do now is just substitute in these values for kinetic and potential energy, the mass and the speed. So the mass of the girl was 25 kilograms. It does need to be in kilograms when you do problems like this in order to get your energy in joules. She jumps off with a speed of 2.2 meters per second. Don't forget to square the speed. And then mass again times the acceleration due to gravity, which I'm using 9.81. You might also see it as just rounded to 10. And that's equal to the kinetic energy at the end here. So now we grab our calculator and we're going to do some squaring first. We do squares first. So 2.2 times 2.2 is 4.84. And I'm going to go ahead and multiply this 4.84 by 25 and by 1/2 as well. So that leaves me with, we're going to round this to two significant figures. I have 60.5, but I'm going to round that to 61. And the units here are kilograms. And then we squared the meters per second. So that's going to be meters squared over seconds squared. And if you remember, if you want, you can pull out one of these meters here and say, okay, I'm going to pull out one of the meters and just multiply it over here. We do that because kilograms times meter per second squared, that's mass times acceleration. That's a force, so that's a Newton. And we have Newton meters. A Newton times a meter we've defined as a joule. So this is 61 joules. All right, and then plus, we have 25 times 9.81 times 1.8 is 440 joules. And that's going to equal the final kinetic energy. So what does this tell us, right? This was the initial kinetic energy, and then this was the potential energy, okay? And that's going to equal the final kinetic energy plus the final potential energy, but that's not there because it was 0. So just to show you, like, this is showing us that the mechanical energy stays conserved the whole time, even though we don't have any potential energy at the end, but the mechanical energy stays conserved. So how much is it? 61 plus 440 is 501 joules of kinetic energy at the end of her splash, right when she touches the ground. So touches the water. So that's all I've got for you in this video. Remember, habit is the battleground of character.